Hey there. In this video I wanted to talk through what is quickly becoming one of our preferred tech stacks for doing analytics and data science workloads against ClickHouse. Now essentially we make heavy use of a tool called Hex, which is a cloud-based notebook environment where data teams can work together to analyze their data using SQL or Python. Now, I'm a big fan of a platform called Databricks, but I realise that half of the reason why I like Databricks so much is the development experience, in that it's notebook based, it's very collaborative, it's polyglot languages, etc. And this stack of these two tools, so ClickHouse Cloud and Hex, are a very similar value proposition. It's a fully managed cloud-based data platform, but with that great development experience on top of it as well. So I'm going to start this demo by looking at the data directly within ClickHouse Cloud. We're going to focus on this dataset, which is the UK property price paid dataset, which is essentially a list of property transactions in the UK. And we have things like the price, the date of the transaction, the location of the property, and a few details about it. We're going to start just by querying the dataset here within ClickHouse Cloud, just to get a feel for it. So we'll first pull the whole dataset back. It's multiple millions of rows, so I'm going to cancel that. But maybe if we do an aggregation, I'm going to aggregate by the town, so the town where the property is situated, and the type, which is terraced, semi-detached, detached or other. And we are going to aggregate them and find for each category the average price of the property. So I'll give it an alias, and if we order by descending, what we are going to have is a list of the most expensive towns and property types in the whole UK. So we can use this query in a moment as a basis for one of our Hex notebooks. We can see that Gatwick, with properties of type other, are the most expensive properties in the UK, and that is something we should bear in mind as we go forward. So here we are in the Hex environment, and we can see that Hex consists of a number of workspaces, and a workspace can have many members in your team who can all be contributing. In the middle here I have a number of notebooks, and likewise anybody can be contributing code to these notebooks or visualizing the results of them. And notebooks also have kind of different statuses as they move from development into production. If we look at the data sources section, we can see that this workspace has been connected to this ClickHouse Cloud account, which I was just looking at. And that connection is relatively straightforward. We just have a host and port. I'm connecting over port 8443 with HTTPS, and we need a username and password. But integration is native, relatively straightforward. So next I'm going to create a new Hex notebook to connect and analyze the data in our ClickHouse Cloud account. We can see that the ClickHouse Cloud workspace connection is the one selected, and we can choose to start the notebook with a SQL or a Python cell. Here we are looking at an empty notebook, and there's one cell and it's totally empty right now. On the left here we have the schema of ClickHouse Cloud, and if we click on the UK price paid table, we get a list of the columns and the data types, which may be useful. Because notebooks are collaborative environments where anybody should be able to contribute and review the results, it's best practice to add in descriptions as to what the narrative is, the steps we're going through, and the thought process and the findings. So here I've given it a title, and we just say, in this notebook we're going to analyse the prices paid for properties in the UK. If we start just with a simple select query against the UK price paid table, just to check we have connectivity, I'm just going to pull back the first 10 rows. The first query can be a little bit slow just whilst things are getting warmed up, but within a moment we will see the first 10 rows of the table. So to kick things off, what I'm going to do is take that aggregation which we just designed in ClickHouse Cloud and put that into the first cell in my Hex notebook. When we run that, initially what you get is a preview of your results, which is useful when you're iterating, just to check your SQL is correct. But when you click the display column, we'll pull back all of the rows, and we can see that there were 6,000 rows in that aggregation, and it took 2 seconds to bring them into Hex. So Hex has this feature where we can kind of daisy chain the cells and query the results of previous cells, which avoids things like CTEs and embedded selects and things like that. And we can build up the analysis as we go. In order to make that work, what we do is we give each output of a cell a name, which effectively names the data frame. So here I'm going to call that one average price paid by town and type, which is what our aggregation is outputting. In the second cell, what I can then do is query that data frame directly. So I'll do a select star, and again we get the 10 row preview, and if we change to display, we will see the full data set. Now, one thing I noticed just by eyeballing this data set is the average prices are extremely high. So the Gatwick others have an average price of £28 million, which is a very high value. Knowing the dataset a little, I suspect it's because properties of type other are commercial properties. And in this instance, maybe it was a warehouse at Gatwick Airport or something like that. So for the purposes of my analysis, what I'd like to do is filter out those commercial properties and just focus in on the residential properties where people actually live. Maybe that's our requirement. We're not interested in these kind of outlier commercial properties. So I'm going to filter out where type is not equals other. And sure enough, I'm now down to 5,000 rows. We've filtered out approximately 1,000. The most expensive place is Virginia Water, detached properties with an average price of 1.4 million, which is a much more realistic sounding number. I'm then going to do the same again. So I'm going to give the output of the second cell a name, and then I'm going to create a third SQL cell. And we're going to query cell 2, if that makes sense. So we're chaining them together in terms of a dependency graph between the outputs of these different cells. In my third one, I'm going to do something very simple. I'm just going to say limit 5, because maybe for my particular analysis, I'm only interested in the top 5 towns. We can see here that in the top 5, Virginia Water is still the most expensive with the same average price. It's just we have limited the data set to top 5 rows. And maybe that is the data set which we really want to focus in as part of our analysis. So again, I'm going to name that, and then that is ready for subsequent analysis. In the background, what Hex is doing is maintaining this dependency graph between the cells. So we can see that initially we go to ClickHouse Cloud to pull back the data, but then we have the 3 cells which are dependent on one another. And this analysis is actually happening in the Hex environment on a Python compute server, in a Python environment on a kind of compute server. If I hit run, what it's going to do is run through that dependency graph. And because of a dependency graph, Hex knows which cells need to be updated at any one time. If I was to update cell 2, then we'd know that cell 3 would be invalidated in this case, and it would need to be recomputed. So this is very good for kind of ad hoc analysis, interactive analysis, that type of things. It makes things very, very fast. As I mentioned, it's a very collaborative environment where your data engineers and data analysts and data scientists and even business users could log into Hex and see these results. So as I mentioned earlier, it's good to add some narrative to the notebook to describe the thought process and the steps and the outputs and things like that. So that's what we're doing here, just adding a little bit of narrative into the notebook ahead of some of the cells, just describing what is happening. It's just a good best practice, but it illustrates, how this is supposed to be used in reality. So one of the next features of Hex is that it has a kind of basic business intelligence reporting dashboarding capability built into it. So here I've taken those top 5 most expensive towns and just pulled them onto a bar chart. So very simple. Hex also contains things like line and area charts, stacked area charts and stuff like that. And although it's not super powerful compared to some dashboarding tools, it may be adequate for many teams just to surface data visually, what is happening. So some simple BI stuff, and maybe it could help you avoid a separate dashboarding tool. Another key feature of Hex is around this polyglot notebooks. So this idea that we can mix and match SQL and Python and move between the two. So here, for instance, I've taken the data frame, which was calculated in cell 3, and we're accessing it as a pandas data frame within Python. So there we saw we could index directly into the data frame, or here what I'm doing is iterating over the columns of the data frame and printing all of the column names to uppercase. So this is just demonstrating that we are in a Python context and we are working with the data frame which was computed as part of our earlier steps. Now that's incredibly powerful because we can have full imperative logic in here. We can use any libraries from Python. We could train a machine learning model if that was something we wanted to do. As an example of something slightly more complicated, maybe we'd like to pivot the data, which is something which is a little bit tricky in SQL, but it's much easier in Python type libraries. So here I'm going to take the top 5 most expensive areas. We want the index into a pivot table to be towns, and then we're going to have a number of columns, one for each property type, and the cell values are going to be the average price. In this data set, the top 5, they're all detached properties, so it's not a particularly interesting pivot table, but if I temporarily change cell 3 to bring back the 1000 most expensive areas, this will demonstrate that cell 4 has also been invalidated and recalculated, and we now have a realistic pivot table which contains for each area the average price for detached, semi-detached, terraced and flats. So basically just illustrating that we've taken a SQL data set, we've moved into a Python context, and we've applied Python type analysis in terms of a pivot. And again, demonstrating that interdependence between cells in the dependency graph. So very powerful idea, polyglot notebooks, very nice to move between SQL and Python in that way, depending on what we want to do. The next thing I'm going to demonstrate is the application feature of Hex. And this is how we build dashboards and low-code interactive apps for analysing our data, which we could give to business users. So what I've done is click to these icons next to the cells which I'd like to bring into my app. And having done that, I can flick to the app and only those cells will be pulled through. Now, although this looks like a notebook, notice it doesn't contain any of our logic, any of our SQL or Python code. We're only choosing to rendering the results in a way which maybe our business users or as our executives might be interested in doing. Now, there is a really nice kind of development process around everything in Hex. So what we can do is notebooks can move from development to testing to marked as in production. Then we can publish notebooks, which shows that they are available to be used by our users. We can put them behind a username and password, or we can publish them live on the internet if that is something that we want to do. And Hex will also incorporate kind of caching. So what you could do is maybe rerun your notebook once a day, and then it will cache the results, and that will avoid needing to go back to ClickHouse in this instance at the expense of fresher data. You could also just continually rerun and re-hit the database if that is something we wanted to do. Now, notebooks, apps, they're not just about dashboards. You know, although we can display tables and charts, what we can also do is make them interactive by adding things like buttons and checkboxes and select lists and inputs from the users and sliders and things like that. So just to demonstrate this with a really simple example, maybe we'd like to make one of the reports filterable by property type. So I'm going to create a drop-down box with a label of property type, and I'm just going to hard code the values to demonstrate the concept, where we have detached, semi-detached, terraced, and other. So that looks good. And what's going to happen is when the user selects an item from this drop-down list, we want to take the result and insert it into the SQL query as a placeholder. So I'm going to add a where clause, and I'm going to say where the type equals, and then we use this Jinja syntax. And that is going to take the value of a property type select list and put it into the query effectively. So now when I've rerun the query, we can see that they're semi-detached, and when I change the drop-down list to Terrace, the cell is invalidated and the results are pre-computed. I can then add this control to my app, and if I go back to my published app, I'm going to republish it with the new control in there. Before you publish, you kind of wait for the notebook to run and the results are calculated. So we're going to publish that. And then if we go back to the app, I'm going to do a refresh, and then the select list has been embedded into the published app. So this is great for, giving people a little bit of slice and dice interactivity to drill down into their data. So that is the highlights, really. For me, this is a really kind of powerful, pragmatic, and also cost-effective stack for analytics and data science. You have ClickHouse Cloud and Hex, and they are fully managed environments in the cloud. There's nothing to configure. In terms of Hex, we're kind of building on top of ClickHouse, and we are giving that collaborative environment where, data engineers, data scientists, data analysts, and even business users can all look at the same data sets and the same set of analytics and build them out together with things like role-based access control. So that's great. We also have elements of development process in there. So notebooks move from being exploratory to being in development to being published and available to use. We have the polyglot language element where, people who are more comfortable with SQL can work in that. But then you could also change over into Python where appropriate if you want to do kind of data science or imperative analysis of your data. So it's very kind of flexible. And then finally, we also have the ability to deploy kind of, I don't know if I'd call them, maybe you could call them low-code apps, or if not, at least like quite interactive dashboards, which may avoid the need for, more complex dashboarding tools or developing applications. So all in all, I think this simple technology stack, it ticks an awful lot of boxes for companies who are looking to analyze their data with high performance. So I'll leave it there. If you would like to learn more about how this could look in your environment, please do reach out. Happy to have an informal conversation about whether this stack would meet your needs. Thank you.